In this video, we're going to name ketones, and a ketone functionality is one in which I have a carbonyl and I have two carbons attached to it. So in this case, this is acetone. There's a carbon here, a carbon here. And we're starting to get into the class of carbonyl compounds, and we should actually take a look at a few of them. A ketone has two carbons attached to it. An aldehyde has one carbon attached to it, and the other side has a hydrogen. An ester has a carbonyl functionality here, but as well there's an oxygen group, so this whole thing creates the ester group. We can get into an amide, where again there's a carbonyl, but instead I have a nitrogen group here. And so now instead of the ester, which contains two oxygens, I have an oxygen and a nitrogen, so this is the amide group. And finally we can get into, we have the acid chloride, which has the carbonyl group, but it also has a halogen attached to the same carbon. And at last we have the carboxylic acid, which has the hydroxyl group and the carbonyl group attached to the same carbon. Now in this class as well is the nitrile. And the reason why this is in it, and it seems odd, so we have a C triple bond N, and you think, why is this a class of carbonyl or acid derivative? But it turns out that if you hydrolyze this, you can go directly to the carboxylic acid, and that's why they consider it as an acid derivative, because eventually you can contain a carbonyl. So there are two ways to name ketones. The first one is by, it's similar to the ether and the acetylene compounds. I can name it as the alkyl-alkyl ketone, and we'll see an example of that. And but the proper one is more of the IUPAC. So with the IUPAC, what happens is if I have a straight chain substituent, let's say for example I have a butane, instead of calling it butane, and with the E, I'm going to put an O-N-E at the end. So this is butanone overall, and it's on the 2 position, so this is 2-butanone. We may not have to put the 2 because there's only the 2 carbon essentially that this can go on. If we wanted to name it by the alkyl-alkyl method, on one side is a methyl group, on the other side is an ethyl group. So we could call this ethyl methyl ketone. So if we try this out, we have 1, 2, 3, 4, 5 carbons. Since the ketone is on the right side, we'll call this the 1 carbon, 2, 3, 4, 5. This is a pentane group, but we're going to call it pentanone. And it's in the 2 position, and we need to denote that. So the ketone has higher priorities than the alcohol and the alkyl halides. So if we were to add on another group, for example, the alcohol group here, this would still be a 2-pentanone, but I would need to indicate that there is now a hydroxy, and it would be in the 1, 2, 3, 4 position. So I have a 4-hydroxy, 2-pentanone. Hopefully you can read that at the end. And finally, if the ketone is on with another substituent that is higher priority, and I always give an example as a carboxylic acid, this gets the name. The carboxylic acid is the number 1 priority out of all the compounds. So it's the number 1 priority, which means then in the 1, 2, 3 position is this ketone, and we call it an oxo. So that gets the prefix of oxo. So in the 3 position we have a 3-oxo. It's a 1, 2, 3, 4 carbon chain. So this is a butanoic acid with a 3-oxo. And that will tell us that we have a ketone in the 3 position for butanoic acid. The aldehyde is also higher priority, so if we were to have both a aldehyde and a ketone, the aldehyde gets the priority, so it's the number 1 carbon. 2, 3 is an oxo, so we know we have a 3-oxo. 1, 2, 3, 4, this is a butane, and we call it butanal, Al for the aldehyde. We don't have to indicate a number because an aldehyde can only exist essentially at the end of a group because it needs this free hydrogen. So typically if it is the highest priority, then we don't have to indicate what carbon it comes from. It's indicated it's on the number 1 carbon. But if you want to be safe, you could put it in there. We'll try another one where we use a double bond in here. So the ketone is a higher priority. 1, 2, 3, 4, 5. So this is a pentanone. I'll write that out just fully. Pentanone. But we know that we have a double bond. So the A we want to change into an E. So somehow we want to get pentenone. This indicates a double bond. This indicates that we have a ketone. Because now we'd like to indicate where they are located on the molecule. This gets the priority, so we want the 2 for the ketone. The double bond would come here. It's in the 1, 2, 3 position. That's where it starts. And we begin it with the pent. So pent 3-ene 2-one.